Mechanics 1, Physics 101. This is the first freshman course. Mechanics 1, Physics 101. What is mechanics? Mechanics is the branch of physics that study about motion of an object and its cause. What is the characteristics of motion of an object and the cause of motion is studied under mechanics. There are two subcategories of mechanics. Mechanics can be categorized into two, kinematics and dynamics. Kinematics is the branch of mechanics that study about the motion of an object without its cause. For example, about motion of an object, uniformly accelerated motion, uniform motion, so and so on is studied under kinematics without the cause of the motion, Whereas dynamics is another category of mechanics which study about the cause of motion. What cause motion? That is simply directly related with force, the cause of motion. Under this, the first chapter 2 of this course is vector. Let's start from vector. Physical quantity can be categorized into two: a scalar physical quantity and a vector physical quantity. Scalar quantities are those physical quantities that can be expressed only by magnitude. For example, mass. Mass can be expressed only by magnitude. 5 kilogram, 3 kilogram, 100 kilogram, it is simply expressed by magnitude. No direction is important adding on mass. 5 kilogram towards east, it is meaningless. Time, 5 hours, 3 hours, it is meaningful without direction. Therefore, mass, time, distance, speed, they are said to be scalar physical quantities. Vector physical quantities are those physical quantities that expressed both by magnitude and by direction. For example, displacement. Displacement is vector quantity. For example, if the distance between your home and the school is 5 kilometers, if you tell someone the distance between the school and the home, if you say simply 5 kilometers from the school, it is meaningless. 5 kilometers to east, to west, to north, to south. Additional information is needed for vector quantity. 5 Newton force applied on the box. 5 Newton force is applied on the box. Towards what? Towards east, towards west. Another information is needed for vector quantity. That is called direction. Magnitude plus direction, that is vector quantity, whereas scalar quantity is expressed only by magnitude or sign. This is the difference between vector quantity and scalar quantity. Next, we will see about resolution of vector. Resolution of vector. Resolving or resolution of vector means decomposing a single vector into components. For example, in xy plane, in two-dimensional plane, let's say this is x and this is y. Vector A is along this direction, angle theta here. So this single vector, if it is decomposed into vector along x-axis, vx, and vector along y-axis, let's say this is a, y. A single vector, vector A, is decomposed into vector along y-axis and the vector along x-axis. Therefore, vector A is equals to vector ax plus vector ay. This is also equal to ax in the I direction plus a1 in the direction. This is unit vector along x-axis, that is I, and unit vector along y-axis is j. Unit vector I and j. So the magnitude of this vector is given as magnitude of vector A, is written in this form, which is equal to the square root of ax square plus ay square. This is the magnitude of the vector. And the angle between this vector and this vector is given as tan of angle theta is equals to tan theta is equals to opposite side, the magnitude of this vector ay, magnitude of this vector over hypotenuse, magnitude of A. This is the way of calculating this angle, the way or the method of calculating this angle. Simply, if this is expressed in 3 dimensions, this is 2 dimensions, x and the y. If this is expressed in 3 dimensions, vector A is equal to vector ax plus vector ay plus vector az, 3 dimensions, x, z, and y. This is, let's say, this is x-axis, and this is, let's say, this is y-axis, and this is z-axis. Unit vector along x-axis is I, unit vector along j direction, along y direction is j, along z direction this is k. So vector A is equals to ax in the I direction plus ay in j direction plus az in k direction. The magnitude of this vector, vector A, magnitude of this vector is equals to the square root of ax square plus ay square plus az square, This is the for 3-dimensional vector. This is for 2-dimensional vectors. The other point is addition of vectors. How we can add vectors? Adding a scalar quantity is different from adding vector quantity. We consider the direction of vector while we add vector quantity. For example, 3 kilogram plus 4 kilogram, it is simply 7 kilogram. But 3 Newton to east direction plus 3 Newton west is different from 5 Newton. Addition of vector is different from addition of vector quantity. We take under consideration about the direction of vector while we add vectors. Addition of vectors. Let's say vector A is equal to 3 in I plus 2 in j direction plus simply k, and B, vector B is equals to I plus j plus k. Vector A plus vector B is equal to 3i plus 2j plus k plus this vector I plus j plus k. So this is equal to 3 plus 1. Here the coefficient of I is 1, I plus 2 plus, this is also 1, j plus 1 plus 1 times k. This is equal to 4 in the I plus 3 in j plus 2 in k. 2 in k. Addition of vectors. Direction is taken under consideration. 3i, I added with I, j with j, 2j, here 1, k, 1, the coefficient 1, 1, 3 added with 1, I added together. Because 3i plus 1j impossible to add together because these two vectors are perpendicular to each other. I is perpendicular with j, which is perpendicular with k. 3 of them are perpendicular. So the direction of I and j are not the same. So when we add vectors, we consider the direction of vectors. The direction of vectors. The other point is multiplication of vectors. Multiplication of vectors. The first one is scalar product or dot product, or we can say dot product. Let's say vector A is equal to I plus j plus 3k, and vector B which is equal to 2 in the I plus 3 in j plus 4 in k direction. Now the dot product of two vectors is given as A dot B, which is equal to A dot B is equal to AX BX plus AY BY plus AZ BZ. So AX 1 times BX 2 plus AY is also 1 times BY 3 plus AZ 3 times BZ 4. Therefore, this is equal to 2, 5, 12, 17 units. Scalar. The dot product of two vectors is scalar. Therefore, A dot B is equal to AX BX plus AY BY plus AZ BZ. There is also another mathematical expression for dot product. A dot B, which is equal to magnitude of vector A times magnitude of vector B times cosine of theta. Where theta is the angle between vector A and the vector B. It is possible to use this expression or this expression to determine the dot product of two vectors. The magnitude of vector A times the magnitude of vector B times cosine of theta. The other point is vector product or cross product. Two cross product or vector product. Cross product or vector product. Let's say vector A, the cross product of vector A and B is equal to, the cross product of these two vectors is equal to magnitude of vector A times magnitude of vector B times sine of theta times sine of theta. Or let's say A is equal to, vector A is equals to AX in the I plus AY in J plus AZ in K direction, and vector B is equal to BX in the I plus BY in J plus BZ in K direction. So to calculate or to determine another mathematical expression for cross product, let's say the I, J, and the K, A cross B, for A cross B, here AX, BX, BZ is written. This is AX, AY, this is AZ, BX, BY, and the BZ. Now A cross B, vector A cross vector B is equals to AY BZ. You ignore the first part. AY BZ minus AZ BY, AZ BY, AZ BY in the I direction plus, for J direction, we ignore this part, AZ BX, AZ BX minus AX BZ, AX BZ plus in J direction here, plus for this part, you ignore this and you use this two, AX BY minus AY BX in K direction. This is also another expression, mathematical expression for cross product. Generally, if two vectors are the dot product of two vectors is scalar. Finally, the dot product of two vectors is scalar, whereas the cross product of two vectors is vector. The result of cross product is vector, whereas the result of dot product is scalar. If two vectors are perpendicular, their dot product is 0. But if two vectors are parallel or anti-parallel, their cross product will be 0. The other point is the dot product of A dot B is equal to B dot A. A dot B is equal to B dot A. Dot product is commutative, this means. But A cross B is equal to the negative of B cross A. A cross B is not equal to B cross A. A cross B is equal to minus B cross A. A dot B is equal to B dot A. Vector product is not commutative. Scalar product is commutative.